Question 4.17 from Module 4 homework. They give you the following reaction that 2 moles of aluminum react with 3 moles of chlorine gas to produce 2 moles of aluminum chloride. And they ask how many grams of excess reactant are left over at the end of this reaction based on having 0.414 moles of aluminum in the reaction and 1.43 moles of chlorine in the reaction. Before we get started, just be careful that these numbers are variables. So your numbers might be slightly different. So just be careful. The steps will be the same. So this is a limiting reagent calculation, and then it's a little bit beyond that because instead of just finding the limiting reagent, we need to find not only the limiting reagent, but what is left over. So I would convert both of these to kind of see, based on the aluminum, how much chlorine would I need? Based on the chlorine, how much aluminum would I need? So I would just stay with the reactants to say, okay, for every 2 moles of aluminum, I need 3 moles of chlorine. And then for the chlorine, right, for every 3 moles of chlorine, I need 2 moles of aluminum. This is going to help us see which one is the limiting reagent in this case, or the limiting reactant in this case. All right, so 0.414 times 3 over 2, and I get 0.621 moles of chlorine. And I'll talk about this number in a second, but I want to do the second calculation first to get about 0.953 moles of aluminum. So what this means is, based on the 0.4 moles of aluminum in the reaction, if all of this aluminum was used, we would consume 0.621 moles of chlorine. I go down here and look, I've got 1.43, so I've got more than enough chlorine for this reaction. So chlorine is not my limiting reagent. That identifies aluminum as the limiting reagent. And we can confirm that by looking over here. Based on all the chlorine in the reaction, 1.43 moles of chlorine, if all of that chlorine reacted, I would need about 0.953 moles of aluminum. I have a lot less than that. So that confirms that aluminum is my limiting reagent. All right, we're not done there. We need to find excess and how much excess. And so this is why I stuck with just the reactants and didn't worry about how much product is there, because they want to know excess reactant left over. That's where we can take this number, right, the 0.621 moles of chlorine. That's how much chlorine would be consumed when all the aluminum runs out. Well, I started the reaction with 1.43, so all we have to do is subtract. Okay, I had 1.43 moles of chlorine in the reaction. I'm going to use 0.621 moles of chlorine actually in the reaction, so I can subtract those two, 1.43 minus 0.621, and we're going to get an excess of about 0.809 moles of chlorine. We're not done there because we wanted to know mass of excess, so how many grams. So the last step, okay, I've got 0.809 moles of chlorine. Right, we go to the periodic table and look up the molar mass of chlorine, right? For 1 mole of chlorine, I need to have 70.9 grams because monoatomic chlorine is 35.45. So multiply 0.8 moles by 70.9, and I calculate an excess of about 57.4 grams of excess chlorine. All right, so this was an involved calculation because not only was it limiting reagent, but then once we identified limiting reagent, we had to use that to say, okay, when all the aluminum's consumed, that's how much chlorine I would need. Well, I started out with more than that. So I'm going to subtract what was consumed, what reacted, and then use that difference to find. I'm going to have leftover chlorine, and then I can convert the moles of leftover chlorine to grams of leftover chlorine in this reaction.